So let's look at what velocity, displacement, and acceleration is all about. Velocity is speed in a specified direction, whereas displacement is distance in a specified direction. Displacement can also be seen as average velocity times time. Acceleration is the time rate of change in velocity. Mind you, both velocity, displacement, and acceleration are all vectors. Distance time graph. The slope of a distance time graph is equal to the speed of a body. Please take note. The slope of a distance time graph is equal to the speed of a body. As you can see on the graph, a steep slope that starts from the origin and moves upward shows uniform or steady speed. The steeper the slope, the more the speed. Whereas a straight line parallel to the time axis tells us that the body is stationary. For a stationary body, the speed is 0. Since the slope of a line that is parallel to the time axis is also 0. A line that is tipping downwards or bending downwards shows that the body is reducing in speed. So let's look at the velocity time graph. The slope of a velocity time graph equals the acceleration of the body. When an object is moving with constant velocity, the line on the graph is horizontal, indicating 0 slope, and hence no acceleration. So uniform velocity is described by a line that is parallel to the time axis. In that case, we say that the acceleration is 0 when the velocity is constant. Also, constant acceleration is shown by a straight line that starts from the origin. The purple line tells us that the body is speeding upwards or is moving with increasing velocity. So let's look at a solved problem for us to have a better understanding. Here is a velocity time graph, and we are to find the area under the velocity time graph, or the total distance covered. If you look at the light blue figure, is a triangle, and the dark blue figure is a rectangle. So the total distance covered is simply the area of the triangle plus the area of the rectangle. And what's the area of the triangle? Half base times height. What's the area of the rectangle? The area of the rectangle is length times breadth. I hope you get that. So if this finger extended further to give us a trapezium, or just what have you, then we'll also consider the shape in looking for the distance. So let's look at equations of uniformly accelerated motion. The motion of a particle along a straight line at a constant acceleration is called uniformly accelerated motion. The 4 equations of motion are V equals U plus AT, S equals ut plus half at squared, V squared equals U squared plus 2as, and S equals half U plus V. Take notes. V here is the final velocity, U is the initial velocity, A is the acceleration, and T is time. S is displacement, please. S is not distance. So take note. When you are solving problems on linear motion, to know which of the equations to use, you consider what is given and what is not given. For instance, if you are given find initial velocity, you're given time, and you're also given acceleration, then you can use the first equation, V equals to U plus AT, to find the final velocity. Also, if you are given initial velocity, time, and acceleration, you are told to find distance. Then you use S equals ut plus half at squared. Let's look at an example. Now, when it comes to motion under gravity, it's a bit more complex. This is because the equations of motion take a different shape. If we are talking about upward motion, is minus g, as gravity acts downwards, and if we are talking about downward motion, is plus g. This question says a rifle is fired straight upward at the ground level, and the bullet leaves the barrel at an initial speed, that's u equals 315 meters per second. Determine the highest point it reaches, the time to reach the highest point, the return time to the ground, and the speed just before striking the ground, neglecting air resistance. So how do we go about this question? At the highest point, the bullet comes to a momentary stop. That is to say, at that highest point, it stops temporarily before falling back